Hi everyone. I hope that you're enjoying Unreal Fest as much as I do. And thank you very much for joining me and talking about optimizing real-time strategy games. And just to make really sure that we are on the same page here. So this one is actually about the bandwidth side of things. Actually, replication graph helps a lot with CPU as well, but this is not the focus of this talk. This is just what you automatically gain by using replication graph. And so replication graph will be part of this talk. But actually, I'm going to take you on a short journey for optimizing one of our games when it comes to bandwidth consumption. And so we're going to go step by step through it. And you're going to make all the learnings together with me here, some of which might be super obvious to you, some of which might blow your mind. And I hope I find some middle ground for each and everyone in this room. So who am I? I am Nick. I'm working at Dedelic Entertainment in Hamburg in Germany. And I also happen to be one of the original developers of Hostile Worlds, which is an RTS game which has been developed with the UDK back in the days of Unreal 3. And why is that important? Because right now we are working on an RTS again, which is called A Year of Rain. So, it's been announced a few weeks ago. And with A Year of Rain, we are trying to create a real-time strategy game in a fantasy setting for PC, desktop platforms, very, very classic. And it's multiplayer, which is what all of this talk is about, right? So just to give you a quick impression of how the game looks, so it's basically a very classic RTS game with all the kinds of stuff in it that you would expect. So there's resources, there's units and base building, there is orders, which I've been talking before earlier today. There's all kinds of detailed information about the status of your units. There's some kind of minimap. There's heroes. So all kinds of stuff that you would expect from a classic real-time strategy game. And today, I'd like to talk to you a little bit about how to improve the network performance when it comes to bandwidth consumption in A Year of Rain, and we're going to take a closer look at the network profiler, at replication graph, and at other small tweaks that you can do for your game to improve on that. And so before we start, we need to make sure that we have a very mostly deterministic testing scenario. Otherwise, we wouldn't be able to compare the numbers, right? It's impossible to understand how well we are doing if we don't have some kind of mostly deterministic testing scenario. And in our case, we've been creating like a small arena map with a representative amount of trees, which might be important in a minute. Representative means with respect to usual gameplay, so for larger maps. So for this small map, there's an unreasonably high number of trees, but this better reflects actual gameplay in A Year of Rain. Then we're going to spawn 20 units per player, and we're going to have them attack move towards a central location in that map. Attack move, for those of you who are not familiar with that term, is an RTS order which has all of your units move towards the location and engage all enemies on their way there automatically. And then we're going to take a profile of exactly 30 seconds just to make sure that we are able to compare numbers. And this is what that looks like. So there's our arena map. We're just taking a look at the red player here, engaging with the blue player forces. And there's also like a small clock over there, and as soon as it hits 30 seconds, we're just going to stop our capture, and then we've got some time where there's no combat happening. There's some time when there's combat happening, and so this is basically our case where we're measuring our performance. Now, how to measure network performance? It's depending on what you're using, it might not be as obvious how to do that. There are generic tools out there, but fortunately, Unreal Engine has got covered us here as well. So there's a network profiler that has been shipped with the engine, which is a standalone tool. It shows the bandwidth contribution of all your actors and breaks it down to RPCs, which are just functions that are called remotely on a remote machine, like the client that wants to execute some action on the server or vice versa, and properties, which means properties that you've been flagged as replicated, and the engine will make sure that these are automatically replicated whenever the values change. And it's worth noting that servers, so when you run a recording session, this is the first step. So you just have your game create some stats file where it just keeps track of all the bandwidth that's been used up by your actors. And afterwards, you take a look at the profiling session in the network profiler. And it's worth noting that the server is always recording everything, whereas the client only records what the client knows about, and that's basically just the RPCs sent from the client. So in most cases, that is not of super much use to you. So you'll make sure that you always want to record these profiling data on the server side. And how do you do that? Enabling the network profiler, when you try to figure it out with yourself with the official documentation, usually points you to passing some kind of command line argument when starting the server. Just pass network profiler equals true, and then the server will automatically start the network profiler whenever a new word is loaded and ready. And so even if you've got some kind of you're losing seamless travel, there's been a talk yesterday, and you have some kind of lobby maps involved or transition maps or so, then it will make sure that it always starts a new performance capture whenever a new word is loaded up. But this might still not be enough. So you might want to do that from code as well. If you want to have a little bit more control, like in our case, for instance, you want to stop recording after exactly 30 seconds. And so usually you would think you can just call something like this, get a reference to the global network profiler instance, and then call enable tracking. Unfortunately, because there's no engine API macro attached to this one, you can't call it from game code. So you have to use the small workaround, which is recommended across spreaded threads in UDN by just executing the net profile console command. And because there are many ways to do this, and half the times the wrong way is recommended, I'm putting this up here again as well for you. So you have to call, you have to execute that function on gengine, not on world or something like this. And what does the result look like? Now let's just assume for a minute that we recorded the previous session. And so this is how this window might look like with all the data in it. So you've got a graph, which basically shows all the basic bandwidth consumption. It shows other data as well. You can you can just check all the boxes to determine which data you want to see. This is the very basic layout that is shown when you start the tool for the first time. Then you've got all kind of detailed numbers here, like the total outgoing bandwidth broken down into per second, or how many actors have been replicated per second, and stuff like that. And there's other tabs as well over there. For instance, you can break this down by actor. And obviously these you can sort these tables by column. So you can take a look at these ones. Obviously there's a tree, which is consuming pretty much bandwidth right here. We're going to take a look at that in a minute. And you can take a look at the individual properties, which is super helpful, especially taking a look at both of them. And then you can take a look at individual RPCs. Two caveats. In this view, you can select a single frame or a specific time span if you want to, but this will only affect the details view down here. This will not affect the other tabs, as I had to find out the hard time. So selecting a frame or time span in the chart will only affect the first tab. And another one, if you're using set actor label at some point in your editor code, this will affect this profiler view as well. So we built an entire level editor from scratch for A Year of Rain because we have tile-based gameplay, and so Unreal Engine has just very limited support for just painting meshes and stuff like that, especially when it comes to tile editing. So we built our own editor, and this editor actually changed the label and sorted stuff into folders so that the world outliner looks reasonably well ordered, but in the profiler view it looked like this. So because we were changing the names of the actors in the world outliner, we had pretty unique names for each and every single tree, for instance, in our world. And you might want to patch this up for the profiling session. Now let's take a look at our actual bottleneck here. So as already mentioned, we can highlight here that there is a tree at the very top, which isn't supposed to be there, right? So even with very limited understanding of our game, you'll see immediately that there wasn't going on too much with trees in what we've just been seeing, so that might be worth investigating. And when it comes to properties, it tells us that minimal replication tags are consuming pretty much. So what is this? There's been 2 talks about gameplay abilities already today, and gameplay abilities, as we are using as well, are making heavy use of gameplay tags, and gameplay tags are actually part of the plain Unreal Engine. They're not necessarily related to gameplay abilities, but you can use them for just annotating any kinds of objects. We're using this very heavily for validating targets for our abilities, like is this a target unit, is it injured, is it a hostile unit, or stuff like that. And gameplay tags are user-defined hierarchical tags that are stored in default gameplay tags, INI. And you can query for these tags various places in your code if you want to. And taking a deeper look at the code base, you will at some point find this jewel here. There is a Boolean flag that explains or gives us at least a rough idea how gameplay tag replication is working. And by default, it's working by just serializing the whole string and send it over the network. But in our case, it doesn't make much sense, right? Because we have both the client and the server in our hands. They're always on the same page. And so in this particular case, we can rely on the same INI file of the version of the INI file on both sides. And this means that we can just replicate gameplay tags by index instead. And this is done by editing the respective INI file, as we did here. And taking another capture essentially yields that our tree consumption went down from like 1,600 kilobytes to 500, which is a huge gain already. And now taking a closer look at the properties, where minimum replication tags were consuming pretty much bandwidth before. Now, it's not like they're vanished, but they're definitely not our top issue here anymore. So it went down from like 1,300 to, what is this, 50 or 60. So that's good enough for the moment. Now, replicated movement. Trees are still on the top, and replicated movement is still on the top. Now, that doesn't necessarily mean that this is related to each other, but it might as well be. And as Unreal Engine is every so often just about finding all the checkboxes, as we found out, we took a look at this one as well. And there's actually a dedicated flag for this one as well. So there's a breplicate movement flag, which can be checked on or off if you want to replicate any movement-related properties. And it looks like this in the editor. So we unchecked this one for the trees and took another capture. And then trees are still, the trees are still on top, but at least went down from like 500 to 300. And taking a look at the properties that are on top, replicated movement went down, and now activatable abilities is on top. Activatable abilities is another thing that comes with gameplay abilities. But at that point in time, I was like, wait a minute, what's going on here? So we've been yabbling about trees all the time, and this doesn't make any sense. So gameplay tags didn't make much sense, movement didn't make much sense whatsoever, but now abilities related to trees, no, I don't think that is the issue at hand here. So let's take a closer look at the graph again, and let's note that this is maybe not what we want to capture here. So this is a huge spike, which is most probably related to the initialization of the game, so like the initial replication of all the actors that is happening here. And this kind of pollutes all our profiling data here, especially when we're taking a look at the sum of everything that's being replicated. And as I mentioned, as we are unable to select a single frame or just a time span from the graph, we are forced to clean up this data ourselves. So we took another approach, and we tried to skip this initial replication by just skipping the first 2 seconds, essentially. So we set a timer, started capturing profiling data just 2 seconds into gameplay to second 32. And this was the time when we are forced to do this in code and not just by passing some argument. And this yielded much more reasonable results, right? So this is what the graph is actually supposed to look like, at least when it, when I took a look at it. So we had to learn the hard way, so we have to start over again. Let's take a look at it again. Now with the new data, we're turning off all the optimizations we've been doing so far, and we can see that now the trees are just vanished. So even without any of the optimizations we've been doing before, trees are like at 0.0 kilobytes. So that's great. There are still guards and scouts, and these are the two unit types that have been fighting each other. They're on top here, and taking at the properties that are being replicated here. It's minimal replication tags. This is as expected because we just turned off that optimization again, and now applying all the stuff we learned again yields a new result, which basically looks like this. We've still got the guards and the scouts at the very top, but taking a look at the properties that are actually consuming our bandwidth looks now like this. This is much more like expected, right? So replicated movement, and at least in our case, was always taking up a major part of our network performance. And one could say, okay, that's great. That's about it. It's not going to get any better than that. You can purge through the whole UDN, trying to figure things out. Like, okay, maybe we can improve on that. Maybe we can use some other vector quantization to reduce this, or we can replicate movement less often and stuff like that. But maybe there's another way. And it was around that time when Epic was suddenly talking about a new kind of technology. They were introducing an Unreal Engine because they needed it for Fortnite. Good for us. And I'm obviously referring to Replication Graph. So Replication Graph is, and I'm shamelessly quoting from the official documentation here, is a system for improved scaling and network replication. And the original goal by Epic was to support Fortnite Battle Royale, where they were telling that they had 50,000 actors that they needed to replicate to 100 connections. And this is like a huge deal. And actually for them, the issue here wasn't just bandwidth, it's also CPU, because up until Replication Graph, trying to find out what to replicate to whom is actually based on some virtual function, which is just called isRelevant. And so everything that we're going to see from now on, you could actually achieve through isRelevant as well, but then it will hit on your CPU. So we're doing this with Replication Graph instead, so we get both the bandwidth and the CPU improvements here. And the basic idea, if you've been taking a look at the material that Epic released about it, like there's like a 1 hour 10 video about Replication Graph already out there. And then they explain that if you've just got a virtual function like isRelevant, then it's super, super hard, if not impossible, to optimize on that by any means, because virtually everything or anything could happen in a virtual function, right? So up until now, Unreal Engine has been relying on continuously on each frame on the server, call for each actor, this isRelevant function, and hopefully it will yield some reasonable result without taking too much CPU. And in most cases, though, we can safely assume that relevancy won't change on a frame-by-frame basis. So it is reasonable to assume that if something was relevant the last frame, it might be relevant this frame again. But again, with isRelevant being a virtual function, it's impossible to make that assumption because it could return anything. So this is when Replication Graph was introduced. And the idea behind Replication Graph, first of all, programmers love graphs. They've always done so. But the idea behind Replication Graph is that we are going to build nodes, and each of this node is responsible of keeping a list of actors, which is called a replication list. And as these nodes are being managed by, as these lists are being managed by these nodes, they are introducing some kind of state when it comes to which actors are to be replicated to which connection. And this eliminates the need for actors to check whether they should be replicated each and every frame. Replication Graph has been introduced for Fortnite Battle Royale and was experimental in 4.20. And the official documentation stated it was production ready in 4.21. We'll come to that in a minute. But this is the current official state of Replication Graph. So how does it work under the hood? I'm not going to show you actual code here, I guess, maybe one slide, but just to get the basic idea. So when building your own replication graph, you do so in code, by the way. There's no way of doing this in blueprints yet, as for many, many network-related things. There's there's 6 functions that you need to override. And the first one, init global actor class setting, basically says, let's collect all the classes that are ever going to be replicated. So we don't care about some of the classes. We know for some classes that are never going to be replicated. So let's filter them out right at construction time of the whole graph, just to ease the burden. Then there's init global graph nodes. So this one is actually responsible for setting up the graph nodes that are globally responsible of replicating actors to any connection. Think game state, for instance, or other objects that are like pretty much always relevant to pretty much everybody. Then there's init connection graph nodes. And this one is called for each new connection that is made to the server, and is used to determine which actors should be relevant per connection. Think stuff like the player controller, for instance. So the player controller is only ever replicated to one of the connections, and this is a thing that is going to these kinds of nodes. Then there's route add network actor to nodes and remove network actor to nodes, and these are basically just the functions which are responsible of adding and removing actors from individual nodes or replication lists. And then there's the final function, which is called server replicate actors, which has the task of actually replicating the actors. Usually you don't have to do anything in here, like you can just rely on the base class implementation of that one, of your replication graph. But if you want to do something special before this happens, then you may override it and do your own custom stuff here. And each replication graph is consisted of individual nodes, and each of these nodes has just a single virtual function that might be important for you to implement, and this is called gather actor lists for connections. So this is actually what is called for each of the graph nodes to determine what to return. And the very, very basic approach is just to have a node with a list of actors called a replication list and just return that one. And at some point update that list if you're forced to, so you don't have to do so in every frame. So let's start with a very, very simple replication graph, just to get our hands on and just to understand what this is all about and how we can improve on that. So this is the most basic replication graph you can think about, right? I'm trying to use the color conventions here, if they are any type of convention that Epic has been using when talking about replication graphs. Maybe we could turn this one to standard. If this is the second talk ever about the topic, does it make it a standard? I don't know. But I'm trying to fit in line with this one. So we just got one node here. This is the always relevant node we were talking about before. This is a node that essentially replicates everything that's in it to everybody all the time. This is the most simple setup you can have. And it's also the most reliable setup you can have because you are absolutely sure that no player is ever missing anything. However, obviously, that might be too much data to replicate. We started off with that one because we didn't want to break anything, but it broke anyway. Just firing up the server, started a map like we did before, our special, or just the use case we've been seeing before, crashed the server with this one. It was like, okay, this sounds like some pretty rough, pretty low-level, very basic stuff, like init with object, object is null, start replicating, object is null pointer, unable to write sub-object, delete, invalid net GUID. We didn't do anything of that with that. And this is when we refer to UDN and we're asking what's going on here. And together with Epic, we figured out that it might be related to seamless travel because actually there is no example implementation that has ever tried to use replication graph in conjunction with seamless travel yet. But we're trying to figure this out together now. So we were able to isolate the issue related to seamless travel. And so we could just disable seamless travel for us. For those of you who have been watching the loading screen talk yesterday by Epic, know that this might be a sad thing to do, especially in our case, because we would have to rewrite our complete initialization code. We didn't want to do that. So we updated the game. And because and we were at 4.20 and 4.21, the patch notes stated it is production ready now, right? No, at least not for us. So we were kindly and very, very yeah, very, very friendly asking in UDN what production ready actually is meaning with respect to this one. And they were like, oh, who put that in there? I don't know. They meant with production ready, it has been used in Fortnite, so it's reasonable production ready, but it has still, obviously there's still issues with seamless travel. Some of which are already fixed in 4.22, which has been released like, I don't know, last week or so we were unable to confirm that. But for ourselves, that meant that we finally resorted to cleaning up the nodes with the invalid actors ourselves. So if you recall the server replicate actors function that we were talking about earlier, we added some custom code before calling the base class implementation where we ran through all the nodes, checked all the actors for whether they had a valid net connection, because actually not even NetGUID is accessible for us, so we just checked whether it had a valid net connection. This was enough. And then everything went almost cool. But we had another warning which resulted in huge hiccups due to the stack walking stuff, which happens in editor builds. This is related to the size of the replication lists. So in our test map, we had many trees, and all of these were put into some node, in this particular case, the only node we had. And usually there's code in place for pre-allocating some of these replication lists so that the nodes have enough space to put all the actors in there. But, and moreover, if there's not enough space to put all the actors in there, usually they are allocated on the fly. But if they have to do so on the fly for very, very large lists, this causes these errors. So we just allocated a very large list to put all the trees in there, for instance, and then this error just vanished. And then we at least got some kind of pretty laggy variant of what you've been seeing before. So everything was replicated, everything was visible, but the performance was not too great. And that's when we introduced a second, or the other nodes step by step. So there is a class called UBasic replication graph that is shipped with the engine as well. This is not like in a sample or anywhere, but it's shipped with the engine itself. So if you just install the engine, you can take a look at this implementation. And this one has a few more nodes than the initial nodes we've just seen. And this is actually one. There's an always relevant node per connection, which I've already been referring to just for for instance, for replicating stuff that is relevant for each connection, always stuff like the player controller. So still no gains here, but what we did after that is we put in another node which is now pretty specific to RTS games, which actually takes the vision calculation of the game into account. So we're taking a look at the current fog of war on the map, which hides enemy units if you don't have any vision on them because they're on high ground, because they're too far away, or because they're stealth for whatever reason they're not visible right now. And now we can just build a node that basically says we're replicating to each connection only what any actor owned by that connection can see in our game. And so these nodes have this, they have these, this function that I was referring to earlier, like, what was the name of it again? Gather actor lists for connection, and these one usually essentially boil down to these three function names in this case. So the always relevant node builds that list by just putting all the actors in there that are always relevant, obviously. The always relevant per connection by connection node actually, for instance, in our case, use the be only relevant to owner flag of the actor. And for vision, we just delegated the call to what is handled by the visible component in the Year of Rain. So there's a component which essentially knows about the sight radius of an individual unit, and then is able to combine all this in some kind of vision mask. And that is shared across all units, so because maybe some other unit is extending my own vision, and then we can determine which unit is actually visible to us. So that's basically it. Now, if you want to use replication graph in your own game, there's just, I'd say, a single thing to consider. And this is, you have to think about all the actors in our game which are not always relevant, just like always, right? And in our case, we are just able to rely entirely on vision. That's it. And in the Epic showcase, as I just mentioned, there's this UBasic replication graph in the engine. They base it on grid spatialization. So the engine is already shipping these always relevant nodes, these always relevant per connection nodes, and they are even shipping with nodes based on grid spatialization. So you can just create replication graph nodes. You can specify like the size of a grid cell, and then it will automatically handle all the kinds of stuff when actors are leaving the cell, when actors are joining that cell. And this is what helped them to determine which actors to replicate to which connections. Yeah, and in your case, yeah, this is basically the single question that remains when you want to roll your own. Now, for us, it was kind of tough to figure out all of this stuff on our own just by taking a look at basic replication graph. And as I engineer myself, I know that sometimes it just helps to take a look at how others have been doing so. So for those of you who know me, who know Dedelic, who have seen my talk last year or earlier today, know that I always love to close with a single slide with like a small present to the community, following up in Epic's shoes when it comes to we all succeed as a developer when we all succeed. And this is why we made all of this open source again. So everything you've seen today, like the replication graph and the custom nodes we created, all of this is on GitHub and on the Dedelic Entertainment account. And you just feel free to pass by, take a look at it, and maybe open some issues if you in case you've got some questions or even find minor bugs. I don't hope so. And I'm eagerly awaiting your feedback, your messages, and hope this helps. Thank you, everyone.